Okay, section 3.5. We're still going to talk about parallel lines right here. Well, actually, yeah, we are going to talk about parallel lines, but with a little bit of a twist. Let's review just briefly about parallel lines. Let's say these are parallel. How do I know? Do I know they're parallel right now? I don't know they're parallel right now, do I? So usually what they do is they put a, and they usually make it a different color, probably red, and they put an arrow. Let's make this a little thicker so I can see it better. Okay, so they put a little arrow right here and right here. Okay, what does that arrow mean about these two lines? It means that they're parallel. It doesn't mean that they're equal to each other. It means that they're parallel to each other. Okay, so if you have the two lines that you know they're parallel to each other. So if you have parallel lines cut by a transversal, we know about a bunch of angles, don't we? We know that the corresponding angles are equal to each other. We know the alternate interior angles are equal, alternate exterior are equal, and then the consecutive interior. What's true about the consecutive interior? They're supplementary. Okay, so we know all that stuff. But what did all this stuff said? It said if what? If you have two parallel lines, right? Then all that stuff is true. Let's write a few things down. We already said it. Let's write it down. Then the corresponding angles are equal, right? So remember, this is a big if, isn't it? If the lines are parallel, these two lines must be parallel for this stuff to be true. So if the two lines are parallel, cut by a transversal, then the corresponding angles are equal. Then what? Then the alternate interior angles are what? Are equal to each other. What's the other one? The alternate exterior angles are equal. Okay, so we know all that stuff. We also know, what was the last thing I just said? The what? The consecutive. Look how I'm shorthanding this. All right, I was a little disappointed on the quiz because you guys aren't shorthanding the way I said. Okay, I don't want just C for corresponding. I don't want just AI for alternate interior. I don't just want AE for alternate exterior. I want you to, if you're going to shorthand it a little bit without writing out the whole word, this is how I want you to shorthand it. Everybody see this? And I've said that before, if you recall, but I still have people just putting AI and AE. If it's on the test and you put AI, I'm going to mark it wrong, all right? Because I've told you several times now, so if you're going to shorthand it, this is the way I want you to shorthand it. So the consecutive interior angles, what's true about the consecutive interior angles? Are they equal just like all three of these are? No, they're what? They're supplementary, right? So this is just review. So if the two lines, now this is the key. This is what we're going to get to today. If the lines are parallel, then these things are all true. You got that? What we're going to do today is just do a little switcheroo with this, okay? Instead of knowing that the lines are parallel, excuse me, right here we know the two lines are parallel, then the corresponding angles are equal. Then this angle and this angle are equal. Agreed? Then this angle here and this angle here are equal. Then the alternate exterior angles are equal. And then the consecutive interior angles are supplementary. So we know all that stuff if what? If what is true? The lines are parallel. I know I'm repeating this over and over again, but I want you to get this because what we're going to do here in a second. If the lines are parallel, then all that stuff is true. What we're going to do today is this. We're going to start off with just two lines that I don't know are parallel. Now, they may look like they're parallel, but just because they look like it doesn't mean they necessarily are. Okay? So watch this. Here's two lines. Now, if that's all I gave you right there, I didn't put any other symbols, I didn't say anything about those two lines, can you say they're parallel? No. Now, it doesn't necessarily mean that they're not parallel, does it? It just means what? We don't know. We don't know for sure, exactly. Does that make sense? So just because the lines aren't there doesn't necessarily mean that they're not parallel. All right? But if I don't have the lines, don't have those little arrow things, that means I just don't know. I just don't know if they're parallel to each other. Make sense? All right. But watch what we're going to do here. We're going to draw a transversal again, like this. Again, does the transversal make these two parallel? No, because we can have very non-parallel lines have a transversal, right? But watch, let's do this. Remember doing this before? So we'll mark these angles right here. So again, I don't know that these two lines are parallel, do I? I just know that I have two lines. That's all I know. I have two lines cut by a transversal. But what if they told us this? What if they told you, what if angle 3 was equal to angle 6? what if they told you that 3 and 6 were equal to each other? Then guess what you can say about the two lines. Say it again. That's right. Do you see the difference? This says if the two angles are equal to each other, then what? The two lines are parallel. Let's call it L and M. So we could say that line L is parallel to line M. Do you see the difference? In the first one we did, we started off saying the lines were parallel to each other. So we knew the lines were parallel, right? And then you could say all the stuff about the corresponding angles, alternate interior, alternate exterior, consecutive interior. But this time we don't know the lines are parallel. What we're trying to do is we're trying to prove that the lines are parallel. So we have some theorems that say if, what are these two? What's the relationship between these two? 3 and 6 are equal to each other. What's the name? What's the name of the relationship between them? They're alternate interior angles. Very good. Okay, so if the alternate interior angles are equal, okay, do you see the difference? The other one said what? If the lines are parallel, right. If the lines are parallel, then the alternate interior angles are equal. What's the difference here? It says, okay, if I have two lines, not parallel, but if I have two lines cut by transversal, and if the alternate interior angles are equal, then what can you say about the two lines? They're parallel. See the difference between the two? All right, before we started off knowing the lines are parallel, and then you could say all those angles were equal. This time you start off saying, okay, what if you know the angles are equal to each other? Then what can you say about the two lines? They're parallel. You get it? What do you think I could do another one? If what? I started off with alternate interior, but okay, let's leave that one for last. Let's do the other C. What's the other C one? Consecutive interior we're going to leave till the last. Corresponding, right. Okay, if the corresponding angles are what? Equal to each other. So what does that mean? That means if 2 and 6 were equal to each other, okay, or if 1 and 5, or if 3 and 7, or 4 and 8. If I knew that one of those pairs of angles were equal, if I knew that any pair of corresponding angles were equal, then what could I say about the two lines? That the two lines are parallel. Does that make any sense? So what you're going to do is they're going to give you some problems. They're going to say, okay, 3 and 6 are equal. Tell me which lines are parallel. In this situation, it'd be easy. Just L and M would be parallel. Okay. Let's do some more. What's another one? If what? Alternate interior. Right. So let's do that. I'm sorry. Alternate exterior. Thank you. If alternate exterior angles are equal to each other. Okay. So let's go back to the picture. So let's say I knew that 2 and 7 were equal to each other. All right. So if I knew that 2 and 7 were equal to each other, what do you think I can say about those two lines? They're parallel, okay? You getting the gist of this? Now we got one more though. What if they told me somehow that 4 and 6 were supplementary? So if somehow they told me that angle 4 and angle 6 were supplementary, right? So if this plus this added up to 180, if I knew that, if somehow they told me that angle 4 plus angle 6 was supplementary, what could then I say about the two lines? That they're parallel, right? So what can I say here? If what? If the consecutive interior angles are equal, then, I'm sorry, I lied. I didn't really lie, I just messed up. Not equal, what? If the consecutive interior angles are what? Not equal to each other, are supplementary, right? Okay, if they're supplementary, then the two lines are parallel. You see that? So if I know that 4 and 6 are supplementary, what can I say about these two lines? I can say that they're parallel to each other. Make sense? Do you see the difference between what we did before and what we're doing now? It's called the converse. I'll show you something real quick. If you ever take a class, I should probably delve into this a little more in here, but there's only so much you can do in a year, you know. So I try to hit places where I think we need to know. But watch this. You'll see this every once in a while. It's called if P then Q. That arrow means if and then. If P then Q. So what is my if and then? This is my if and this is my then. Would you agree? All right. So if P then Q, that's my statement. But what if I switch it around? What if I said if Q then P? That's what we're doing here, isn't it? Because before, when we first did it, we said if the lines were parallel, then all this stuff was true. But that was our statement. But now we switched it around, didn't we? We took the if part and the then part and switched places with them. Make sense? So instead of if P then Q, because the P stands for the if part, the Q stands for the then part. So if we switch them around, we call this the converse of the statement. All right? The converse. We're not going to get into much detail on this, okay? We're not going to get into a lot of detail on this, but it's good to know. At least you saw it, and if somebody says, well, what about if P then Q, or if not P then not Q? There's a bunch of stuff you can do with this. There's whole entire courses on logic that you do this kind of stuff. Okay, I'm just barely even scratching the surface. Okay, I'm just wanting you to see that. This would be the converse, and that's exactly what we've done. We've done the converse, haven't we? Instead of saying if the two lines are parallel, then the alternate exterior angles are equal, what are we doing? We're switching it and saying, okay, if the alternate interior angles are equal, then the lines are parallel. They're converses of each other, okay? Does that make sense? So in this situation, the statement and the converse are both true. That's not always going to happen with every single if-then statement. On these, it is true, though, that the statement and the converse are both true. All right, let's do an example so you can kind of see what you're going to look at when you do this worksheet today. Let me find a good example from the book. Okay, here's one. They got a line like this, and they got a line like this. About right there. Then they have a transversal. Actually, I can do this. Okay, then they have a transversal. Since my transversals have all been red, let's keep this red like that. Okay? Alright, and they give you some stuff. They tell you that this angle right here is 5x plus 7 degrees. You guys writing this down? Should be. I only see a couple people with pens in their hand. Should be writing this down. This angle right here is 7x minus 21 degrees. And what we have to do is we have to do this. We have to say, what does x have to equal? Are you listening to me? This is very important. What does x have to equal in order to make these two lines parallel to each other? Well, let's take a look at the relationship between these two angles right here. Okay, they have to be the same. Why? What's the name? What's the name of the relationship between these two angles? They're alternate interior angles. Very good. Okay, so if the alternate interior angles are equal, remember what we just did? If the alternate interior angles are equal, then what's true about the two lines? Then they're parallel, right? So guess what we're going to do to these two angles right here? We're going to make them equal to each other. We're going to find what x is, and whatever x is, that's going to make these two lines parallel to each other. And that's what we're doing. It's very, very similar to what we did before. Okay, it's really, they could have said angle L and angle M are parallel to each other, solve for x. They could have done that. But that's not, it's just a little bit of a twist on that question. What they're doing here is they're saying, okay, we don't know anything about L and M, but what should x equal each other? Okay, or what, not equal each other, but what should x equal in order to make this line and this line parallel to each other? All right. So if the two lines were, or if the two angles were equal to each other, that would make these two lines parallel, wouldn't they? So if the alternate interior angles are equal, then those two lines will be parallel. So let's set them equal to each other. So 7x minus 21 equals 5x plus 7. So if this was true, if this statement right here is true, if the alternate interior angles are equal, then what must be true about the two lines? Then the two lines are parallel. Does that make sense? So that's what we're trying to do. We're trying to find out what x is in order to make these two lines parallel. So we set them equal. So let's do the math. Very easy math. Subtract a 5x from both sides. Add a 21 to both sides, right? Get that over here. So we work this out. That's a 2x. That cancels out. That cancels out. And that's what? 28. Divide by 2. Yep. So x is 14. So if x was equal to 14, that's going to make these two lines parallel to each other. If x was anything else, then those two lines would not be parallel to each other. Make sense? So if you wanted to, you could put it in here. 5 times 14 is what? 70. Is that right? 70 plus 7 is 77. So this angle is 77 degrees. What should this angle be if we did this right? It should be 77, right? Let's check to see if it is. 7 times 14. I don't know what that is. 7 times 14, that's 28, that's a 2, that's a 98, minus 21, and what's that? Oh, 77, isn't it? So this angle right here is also 77 degrees. So the alternate interior angles are now equal to each other, which makes what? This line and this line parallel. Got it? We didn't know they were parallel to begin with, did we? Okay, but what we said, we said, hey, look, I got alternate interior angles here. If I make them equal to each other, then I can solve for x. That x is going to make those two lines parallel. It seems very, very close to what we did before when we did that alternate interior angle stuff. All right, and it is. It's very, very close to it. But it's just the converse of what we did before. Okay. Let's see what else. Here's another example. Let's do another example here. Let's make these lines white again, stay consistent. And, alright, here we go. There's going to be a lot of angles in here. This is on the top of page 207 if you want to look. Okay. And then we got, let's make it look a little more like that. And then we'll copy and paste. Put it down like this. Alright. So let's put some angles in here. I'm going to number them just like they do in the book so that if you need to look back in the book, it'll be consistent. 5, 6, 7, 8. This is 9, 10, 11, 12. And this is 13, 14, 15, 16. Yep. All right. And this is LM. Right, that's L and M, and this is A and B. That line is A, and that line is B. All right? So here's what they ask you to do. They say, what if angle 2 was equal to angle 8? What lines would be parallel just from this information right here? Because we don't know that any of these lines are parallel right now, do we? Because there's no little arrow things on there. There's nobody in here said that L was parallel to M or A was parallel to B. So we don't know any of that stuff. But we do know this. This is the only thing that we know, that angle 2 is equal to angle 8. So if angle 2 is equal to angle 8, which lines must be parallel? So what I'm going to do is I'm going to come up here and I'm going to mark it. Watch. Angle 2 is equal to angle 8. So, which line is the transversal? We've had a worksheet where we asked this before. If I got 2 and 8 here, which one is the transversal? It's L, because L touches both of those angles, doesn't it? See 8, it goes from B to L, excuse me, and then this angle 2 goes from A to L. Everybody see that? All right, I hope you're watching. So L is transversal. So what are the two lines then that are cut by this transversal? A and B, that's right. So if angle 2 is equal to angle 8, what's the relationship between them? They're alternate interior, aren't they? So if the alternate interior angles are equal to each other, then the two lines must be parallel. Which two lines in this situation? A and B. So what's my answer? A must be parallel to B. That's my answer right there. Okay? It's parallel. All right, so does it make sense? Let's do another one. Let's do a different color. Let's go 3 and 11. So they tell you that angle 3 equals angle 11. So they tell you that. So what are you going to do? You're going to come up on the picture and you're going to draw it, aren't you? So there's 3 and there's 11. First of all, I like to see the transversal. What's the transversal with angle 3 and angle 11? It's A, right? Because A, see angle 3? It goes from L to A, and angle 11 goes from M to A. So A is the common line, isn't it? So that's the transversal. So what are the two lines that, or first of all, let's do this. What is the relationship between 3 and 11? They're corresponding angles. Everybody see that? They're corresponding angles. Everybody with me? So 3 and 11 are corresponding angles to each other. So which lines must be parallel if 3 and 11 are equal to each other? What is it? L and M, right? Because look, angle 3 hits L and angle 11 hits M. Transversal is A, so L must be parallel. L must be parallel to M, and that would be your answer. So you're going to get some problems that kind of look like that. Hope you guys are paying attention. All right. Does it make sense? All right, so that's the kind of stuff they're going to ask you. I think we pretty much covered everything. I'm going to give you a worksheet. The worksheet is section 3.5. All right, so it's worksheet section 3.5, and there's a page number at the bottom of it. I don't know what it is. Got to get my book to see it. 3.5, it's page 40. Okay, so just in case, I know nobody does this, but just in case you forget the worksheet at school, or you leave it in your locker, you leave your book or whatever, and you got to go online, you got to find it. It's page 40, section 3.5, page 40, and that's what you're going to be doing today. Now, there is a little chunk at the bottom, and you'll look at it and you say, what in the world is that? It says proof, right? And it's got like 2 columns, and it's got a bunch of stuff written here, and then it's got a bunch of blanks you have to fill in. Okay, don't worry about doing that. We're not doing those proofs, okay? Just do one, let's see. Just, I forget what number it is, but do 1 through whatever before this stuff, okay? The stuff that looks like what we did today, all right? And that's it. That's your homework. That'll be due tomorrow. Let me give you the worksheet.